हमारी इसमें से एक नंबर तो पूरा भारी हो गई क्लास के बाद।
मुझे दो नंबर के सेक्शन जो है कि अपने हमारे आने वाले रोमन वर्ड पॉलिसी कुछ चेंजेस प्रोजेक्ट है प्रोजेक्ट किया और दूसरा चेक करके हटा दे।
उन टेक्स्ट में रखने की जरूरत नहीं है, स्विच ऑफ करके अपने अपने बैग में रखो। कहाँ रखा हो?
नहीं बोल रहा है
नहीं, आपने बैग में स्विच ऑफ ब्रेक मध्ये पण बाहेर नाही. इथून जेव्हा क्लासरूम मधून बाहेर जाणार तेव्हाच ओपन करायचं. त्यासाठी रजिस्ट्रेशन फॉर्म फिल अप केला करा. 16 एप्रिलला आले ठीक आहे.
Seventh or eighth class syllabus.
Seventh, eighth class syllabus. Math science का so
तो देखा जाएगा तो पढ़ना है
चलो चलो वो जरा
चलो यार का साथ को
वो जरा
अरे यार ओके या
क्या इवेंट में ये मुझे बहुत देखते हो
इसी जान भी नहीं है
अच्छा है ना वो उधर से ऐसा मारते अरे वो बैठ नहीं देते को इससे बनाया ना बोर्ड
नहीं चालू से
अपने नहीं बताने का गलती नहीं बताने का किसी को भी वो गुलाब जामुन को भी नहीं बताने का डिवीजन के नाम पे डिवीजन डिवीजन सॉरी पता है ना नहीं देखा अरे वो मुझे नहीं मतलब
ऐसा समझे
इधर की है
मूवी पर समझे
हाँ उधर को मतलब सिर्फ उसको मुंह देखा ऐसा लगता है मुझे उसके बिल्कुल भी डेवलप नहीं है मैंने लिटरेचर की स्टडी करी फिर बाद में मतलब ई आर होता है ना
नहीं यार तो भी गलत अरे लिखा था
LITERE तो मैं क्या बोला ERA होता है लिटरेचर
इंग्लिश
फिर मैंने पेज काट के उसको
कुछ भी करना तो लॉ पढ़ना स्पेल करूंगी
प्रोनाउंसिएशन क्या है अरे दोनों अच्छा नहीं
इवन नाउ
मैं फोन पे चलिए सबको
फिर पढ़ कीजिए जनता मैम ने बोला अपना बात में देखो फिर से अच्छे से पढ़ गए
मैम भी हंसी ना
तो
हंसी की नहीं
देखो अच्छे से पढ़ना चाहिए हंसना नहीं चाहिए यू आर नॉट अ क्लास क्लाउड
क्यों फ्री पीरियड था वो
अभी काय का फ्री पीरियड
धर्म शिक्षा था वो फ्री हुआ वो
का
मस्ती होता है उसको
काय का
बस मस्ती होता है कि नहीं
एग्जाम
धर्म शिक्षा में मस्ती होता है
अभी मार्क्स लाइक
ठीक है मैं वो तो रिपोर्ट कार्ड में भी नहीं दिया थर्मोमिस्टर का कुछ वो भी बोलेंगे ज्यादा दिया रिपोर्ट कुछ करेक्शन भी नहीं हुआ है कुछ से तो मार्क्स किधर है बैंक पर है किधर एग्जाम हमारे यहाँ टोटल आर और क्या था वो जीके सबका ग्रेड था उसमें
Evening all. Please proceed. Okay. Please sit down. Where did we stop in the last class?
uniform and all.
We had completed that. So now you are familiar with motion and rest, distance and displacement. Right. Then uniform and non-uniform. Right. Did we cover rate of motion? Okay, rate of motion basically means speed. Okay. So when we say rate of motion, what it means is how fast or how slow the object is covering distance. Okay. So rate means speed. Now, how do we define it? How do we define speed with rate of motion? It is defined as distance covered by an object in unit time. Okay, distance covered by an object in unit time. Or mathematically, we write it as speed is equal to distance upon time. Okay, this is the formula. So in symbols, we can write S upon T. Okay, S is the symbol for distance or displacement if the motion is in same direction. Yes. So, one this right. What's your name? Okay, so we'll see that this is the symbol used for displacement also, as long as the motion is in the same direction, right? So any doubts here? Motion, distance, displacement, uniform, non-uniform. Clear? Everybody's clear?
So the question we did last time, the last one was 8 to 8. So how would it be 0?
How did we get?
How would it be 0 here?
0 meter is displacement.
This is
Yes.
These doesn't position as negative position. This is 0. This is 1.
See, this was the question, right? Look here. What was the last?
60.
60?
40.
40. This was 40? 10, it's okay, 20, 30, 40, okay? So A to A, right? So let's say this was A, this we called B. Where was C? Here?
No, no, sir. C was 40.
And B was 30.
B was 20.
It's okay, so ये था. And so what was the motion? You're saying A to B to C and again back to A, right?
Yes.
So what is the total distance? So A to B 30 plus 10 and then 40 again. So 40 plus 40 distance will be 80 meters, right? What about displacement? देखो A to B plus 30, B to C plus 10, then C to B minus 10, B to A minus 30. Because displacement has sign. I told you, right to left, what is the sign? Negative. Now what is the sum total? What is the total? 0. This is how you get 0. Okay? Anybody else has any doubt in this? These terms? You were present in the last class? So do you have any doubt here? So today we are starting with speed. Okay. So what I was saying is when the distance and displacement are taking place in one direction, like say A to C, what will be the distance and what will be displacement? Right? Both will be 40 only. And when we consider magnitude, then S represents both distance and displacement. Okay. Now next is the concept of average speed. What is average speed? We will define this as total distance. It is the ratio of total distance covered by the object upon total time interval. Now why we need this? See, basically when an object is traveling from A to B, stand the attendance. Six. Let's say so average speed is equal to total distance upon total time. See, so let's say location A is Mumbai and location B is Pune, right? So what is uniform speed? If the object travels with uniform speed, right, constant velocity, it's very rare. Will you travel from Mumbai to Pune with the same speed? No. Somewhere you will stop for signal, somewhere the traffic will be more, and then you'll get free roads. So you're always traveling with a different speed. Meaning, in a unit time, sometimes when no traffic is there, more distance will be covered. More traffic, less distance will be covered in the same time. So speed is never constant in any practical journey. Okay? So let us say you had 2-3 speeds from here to here, let's say divided in 3 parts. Imagine this was say 120 kilometer, right? 0 to 120 kilometer, right? And let us say you traveled with the speed of say 30 kilometer per hour here, per hour, right? Then here you traveled with the speed of 50 kilometer per hour. And then you traveled with the speed of 40 kilometer per hour. Right? So if the unit time is hourly, let us say instead of second, let's say we take the unit time as hour, right? So how many hours are there? You took 3 hours total to reach Pune, let us say. Okay, so here the first in 1 hour 30 kilometers were traveled, right? In the next hour 50 kilometers were traveled. Okay, so 50 will be say somewhere here. And then in the last 1 hour, only 40 kilometers were covered. Array, 1 hour. So is the speed same everywhere? No. So therefore, there is a concept of average speed. So how do you calculate average speed for this example? So what is the total distance? We'll say V average. This is 30 plus 50 plus 40. Okay. Imagine we are removing this hour so that we get distance traveled directly. So what will be speed? 30 by 1, 50 by 1, 40 by 1. Correct? That's the speed. So total distance is this. What is the total time? 1 plus 1 plus 1. So this is 120, right? Divided by 3, which is 40 kilometers per hour. So the average speed is 40 throughout the journey. But between different partitions, you have different speeds. Got the concept? Why average speed? Yeah. So since speed during the journey, yes, may not be. Did you sign the attendance? Who signed the attendance at the reception? Speed during the journey may not be uniform. Right? Hence, average speed is calculated with the help of this formula. Hence, we calculate average speed of the journey as below. Have you understood why do we need the concept of average speed? Because of this. Okay, so whenever we say speed, it is average speed. Okay, unless it is mentioned clearly in the numeric. Right. So any questions here? Chalo, let's close. Next concept is of velocity. What is the meaning of? Unit means 1 second. See, for example, let us say an object covers 30 meter, right, in 2 minutes or in 2 minutes. Okay, object covers 30 minutes in 30 meter in 2 minutes. Then what do you get? So therefore speed will be 30 meter divided by 2 minutes. Right? So in seconds, how much it will be? 30 meter divided by 2 into 60. Sorry, 2 into 60. So I would have said 30 meter in 120 seconds, right? An object covers 30 minutes in 120 seconds. So in 1 second, how much it will be? 30 by 120. Yeah? So distance covered in 1 second. So that is what is meant by unit time. So what you will do is you will divide the whole distance by total time. Then you get distance covered in 1 second, right? So 2 into 60. So how much it will be? 12. 1 by 4. So 0.25. This is 1 by 4 meter per second. That is, it will cover 25 centimeter in 1 second. What is 1 by 4 meter? 0.25. 1 by 4 is 0.25 meter, right? So 0.25 meter is 25 centimeter. Okay, quarter meter. Have I answered or have I confused you? Have I answered? Pretty detailed answer. Anybody else? Any question? Any student who did not attend my first lecture, today's first lecture, last lecture you are not present, both of you. So the video lecture is available. Okay, you can refer that and borrow notes from the friends. So these days it's like as simple as clicking the pictures. Our times we used to borrow notebook. Right? Sometimes we did not return the notebook. Does it happen these days? No. Everything you have to write. Because you understand better when you have example in front of you. So, if someone has written already, can you guess what is velocity? Is this chapter started in your schools? What should be velocity? See the definition of speed and try to guess. Now speed is a scalar quantity, velocity is a vector quantity, not a. So how we will define velocity is, it is defined as the displacement covered by an object in unit time. Instead of distance, now velocity is what? Displacement. So velocity is a speed in a given direction. Got it? Here we are not talking about direction. In case of speed, but in case of velocity, we'll talk about direction. So it is defined as the displacement covered by an object of an object in unit time. It is defined as the displacement of an object in unit time, or velocity is the speed of an object in a given direction. So when we add direction to the speed, it becomes velocity. Right? So mathematically, how we'll write it? Velocity is equal to displacement upon time. Okay. So symbolically, V is equal to S upon T. Again, similar like average speed, an object will never be moving with a uniform velocity. Right? So average velocity is net displacement. Actually, displacement is always between final and initial point. So you can just write displacement for the whole motion. On total time. So whatever equal or unequal displacement it covers, the final displacement will always be final position minus initial position. That will be only displacement for average velocity case also, right? And then the total time will give you the same. Clear? So average. The formula will be same, average net displacement upon total time. Here what it will be S1 plus S2 Sn divided by plus T2. Right? This is your average speed. Okay, very well. So we are using the same symbol for speed and velocity. Just it will depend, like it will be differentiated basis what is the discussion in the numerical. We got your NCERT textbook. I told in the last lecture that you could also do this. So we'll take up some questions. These questions are also given in your volume content solution. So you will hide the solution, right? So open the textbook, page number 100. The question is, are you still writing or finish writing everybody? Yes. Okay. So open the index question on page 100. reads like this: an object has moved through a distance. Can it have a zero displacement? It can, right? So if yes, support your answer with an example. What will you write? When will the object have zero displacement? In a straight line. Then it will, so when illustrate. You're right. But zero displacement. When will it have zero displacement? By moving in straight line. Remember the scenario? When after the motion, object comes back to its initial point. Okay? यहाँ से motion start किया था. When it reaches back to the same point, then the displacement will be zero. So that is the first question. Can you locate it in volume number 64? Page number 64. Keep a notebook. 164. 164. Keep some page to write the answer. Now we will do the second question. Everybody got the question? 164 page पे. The second question is: a farmer moves along the boundary of a square field of side 10 meter in 40 seconds. ठीक है? Answer write करो पहले. Everybody write the answer. That's why next time you'll bring textbook also. What will be the magnitude of the displacement of the farmer at the end of 2 minutes 20 seconds from his initial position? Right? Try to solve it. Have you understood the question? A farmer moves along the boundary of a square field of side 10 meter in 40 seconds. Okay? So imagine the page of the notebook is a square. So once he takes one full round, what is the boundary? 40 meter, right? 4 times it is 40 meter. That's the distance covered. So what will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds? For one round, how much time is needed? 40 seconds. So for how much is he taking around? 2 minutes 20 seconds. So what is the time in seconds? 2 minutes 20 seconds. 140, right? So now, how many rounds you will make then? 40 rounds.
Is given 10 meter and 40 seconds.
Is it 10 meter in 40 seconds? Read again. 10 meter is the side of the field, not the whole field. This is the mistake most students are doing. Dekho, what is the field?
160 will be for that.
Look here. So I think you are making a mistake in reading or understanding. The side of the field is 10 meter. So when he covers a boundary, what is written in the question? Read again.
Farmer moves along the boundary of the square field of side 10 meter in 40 seconds.
10 meter is the side. So what is the boundary then?
40 meter.
40 meter. Okay? So, and what is given? Right? Farmer covers in 40 seconds. How much it covers?
10 meters.
40 meter.
40 meter.
Boundary is 40 meter. Na? Boundary 10 meter. See, this is how the thing gets, the brain gets fixed. It's the question teaches on. Okay? A farmer moves around the boundary whose side is 10 meter in 40 seconds is given. Okay? Moves around the boundary means perimeter. Clear? Boundary is perimeter. So in 40 seconds he moves 40 meter. Right? So therefore, in 2 minutes 20 seconds, that is in 140 seconds, what is the displacement? That's what you have to find.
So magnitude of distance.
Magnitude. Value of displacement. We'll tell you. Distance, if you say, it will be totally different. So in 2 minutes 20 seconds, if it is continuously moving, then where will he reach? So suppose, so how many? So 140 seconds, right? So 140 if you divide, how many 40 seconds are there? 140 is, since 140 is equal to 40 plus 40 plus 40, 120 plus 20. So 40, 40, 40 में क्या होगा? Suppose this is A, B, C, D. So he makes first round here, second round here, third round he completed here. After third round, the fourth round he will go, so he will reach C. Huh? So what is the displacement? 20 meter. Is it the shortest distance to C? So what is the shortest distance to C? This is the shortest distance. So this is how you have to tackle the question. That's a good question. So next question 2 is on page 100. So what is AC? Right? So that is in 140 second. What is the magnitude of displacement? So magnitude of displacement is AC. How do you calculate it? Hypotenuse theorem. So Pythagoras theorem, right? So therefore AC is equal to is 10 meters. How?
AC square is
You know this formula? By Pythagoras theorem, hypotenuse square is equal to sum of square of the other two sides of the rectangle. Of the right angle triangle, right? So now what it is? Is everybody with me on this? Is everybody with me? So 100 plus 100, it will be 200, right? So root 200, therefore AC is equal to root 200. So which is like 2 into 100, right? Or 100 into 2 is 200. What is square root 100? 10 root 2. What is root 2? 1.414, right? Okay, so this will be 14.14 meter. Okay, this is the displacement. But displacement also requires directions, right? So what is the direction? So suppose you draw the direction, if this is east, this is west, then this will be north and this will be south. So where is he? In northeast. Correct? So now the answer is complete. So if you understand this question, you will understand everything about distance, displacement, okay, what is asked. So this is a logical question, you have to break it and then answer it. It's given in the question. Yes, yeah. This is the question it was asking. What is 10 meter? 10 is the side of the field. And what is 40 second? 40, not one side, 40 second to cover the boundary perimeter. Read the question again. So what is the correct technique of reading a question? Keep your finger on the question and then read along. Okay? Then you will be able to capture the data. Read the question again. Again, you are not keeping the finger. Then stop. Once you finish 40 seconds, stop. What is it? Read it. Say that and read it.
Marker moves along the boundary of a square scale of height 10 meter in 40 seconds.
What does it mean? A marker moves along the boundary of a field whose side is 10 meter in 40 seconds. Goes along the boundary. So when you say boundary, it is the full circle or full round. Okay? Whose side is 10 meter? Clear? So in 40 seconds, how much he moves? 40 meter. 10 plus 10 plus 10 plus 10. Clear?
Like this.
Actually, the solution is given. If you want to write better, I think this is the approach I have followed. I don't know what is the approach in the volume. So read the solution in the volume. If you are able to understand that, then don't write it.
So the answer is C.
Answer is same, but solution explained in the volume. This is better, right? So that's why I've given you this. Is there any diagram in the volume?
So
Yes.
this is used.
Distance is used. So distance is from here to here to here to here, but this is displacement, AC. So if you understand the concept of displacement in this chapter, this is the only concept to be understood. Everything else is linked with displacement, whether it is velocity, acceleration. Okay. So draw the diagram also. When I say S means what is the displacement? 140. So now I have broken 140 in terms of 40-40 because I know in 40 it will cover one round. So then what is left is 20. So 20 पे कहाँ पहुँचेगा? इधर ही पहुँचेगा, right? So if it takes 40 seconds for full round, 10 मीटर के लिए कितना लगेगा उसको? 10 seconds, है ना? So what is the distance covered in unit time? 40 by 40, 1 meter in 1 second. So 20 meter को कितना लगेगा? 20 seconds. है ना? That's how we have. Now the third question. Those who have finished, read the third question. So it's a true false question. So who will read? You read.
Which of the following is true for displacement? It cannot be zero. Its magnitude is greater than the distance traveled by the
One at
object.
a time. First question. Displacement cannot be zero. True or false?
False.
False. We have seen displacement can be zero. In what case?
So it's really like
When it comes back to the initial point. Second,
Its magnitude is greater than the distance traveled by the object.
is it true? It is false. Displacement is never greater. At most, it can be equal. When will it be equal?
when it is going in
The same direction. Okay? Very good. So So you have understood. Now we'll do example 8.1. So in the textbook, this example is, I'll just write it on the board, the given data. So I'm doing example 8.1. This is on page 101. So what is, it reads like this. An object travels 16 meter in 4 seconds. So given in time 4 second, distance covered is 16 meter. Okay? An object travels 16 meter in 4 seconds, and then another 16 meter in 2 seconds. In next 2 seconds, distance traveled is 16 meter. Okay? 16. What is the average speed of the object? Right? Find the average speed is what? For the given question, what is the average speed? Yes, you have. So what is average speed for the given question? That will be S1 plus S2 divided by E1 plus E2. S1 is 16, S2 is also 16, E1 is, first is 4 and 2, right? This is 32 divided by 6. So meter per second. So how much it is? 6 5s are 30, right? 6 5s are 32. So point 6 3s are 18, right? 5.3 meter per second. Right? It will be 5.3333 like that. Is it clear? Everybody understood how we did it? Because in this question, the total journey is for 6 seconds. In the first 4 seconds, it covers 16 meter only. So it is slow, less speed. Then the speed increases because now it is traveling 16 meter in half the time. So therefore it is a case of average speed. Is this question given in the volume? No. Okay? So this is understood. So write this down. Yeah, this is correct. So what he has done is he calculated, he added these two and he added these two. So instead of writing it like this, he straight away wrote this. That is also possible. Okay? Because he knows what he is doing. So that's fine. Yeah, average speed is defined as total displacement. No? D average is equal to total distance upon total time. See what, have you taken the notes? Average speed formula you check. Total distance upon total time. So what is total distance? This is S1, this is S2. So 16 plus 16. What is total time? 4 plus 2. See the formula, right? So if you have a question, please ask. So the more numerical you solve, it will become very easy for you. Yeah? When learning in terms of passages, sometimes it is confusing. Okay. So we now have covered velocity and what is average velocity, right? Okay, next, average velocity, one formula is this, displacement upon total time. There is one more formula for average velocity. If during the motion the velocity of the object changes at a uniform rate, okay, then average velocity, so initial velocity plus final velocity upon 2. What is u? Where u is equal to initial velocity U is initial velocity, A is final velocity. Okay, what does it mean? Suppose, so it's like velocity is changing. First it was 10 meter per second, then it became 20 meter per second, then it became 30 meter per second, right? So this was in the first second, third, likewise. So throughout the journey, like every second, the velocity is increasing by 10 meter per second. Okay, so this is changing uniformly. Velocity of the object changes at a uniform rate. Uniform matlab fixed rate. What is that fixed rate? 10 meter per second every minute. Okay, so only in such kind of a scenario, you can take the average velocity as mean of the initial and final velocity. Clear? So this is a special case, whereas that is a general case. Okay? So depending upon how the question is asked, you will use one of the formula. Clear? So we'll now do the next question. Yes.
Sir, can you give an example about this?
Example about this. So let's see if we have an example of this. चलो एक एग्जांपल करते हैं नेक्स्ट वाला एग्जांपल 8.2 we'll have the only he has the textbook, right? So we'll do the in-text question. I think all of you have the in-text, and then we'll go to the next example 8.2. We'll wait for this example. First we'll do those kind of thing. Then we'll see how different it is. Okay. Now, so 8 distinguish between speed and velocity. That is the next in-text question. That we have already covered in the theory. Everybody is clear on that? Speed is distance upon time. Velocity is displacement upon time. Under what conditions is the magnitude of average velocity? Acha, I gave the example, you did not notice it or what?
I didn't know, but I did.
That was the example, like how different example can be?
In that, the initial velocity was 10
10 meter per second, yes.
and final was
30 meter per second. And this is like 20 meters per second. That's why I was confused. Why she is asking another? This is the example I gave.
I didn't understand.
So this is u, the first velocity, and this is the final velocity. You don't take into consideration. And why it is uniformly changing? Because everywhere it is increasing by 10 meter per second. Okay. So now what will be average like? N plus 30 divided by 2. Why I got confused? I precisely gave the example. Then you ask give the example. Then like what? This is the example. This was the example. So how much is this? 40 by. This is 20 meters. Okay. Let's come back to this. Under what conditions? Now these are conceptual questions. Under what conditions is the magnitude of average velocity of an object equal to its average speed? Did you get this question in your notebook? So what is the second question? Under what question? Under what condition the average velocity is equal to average speed? आंसर तो नीचे लिखा है क्या आंसर
When the body moves along a straight line with varying speed.
Body moves along the straight line without changing the direction. So even though the speed changes, right, but the average will be the same only. Let's say a body starts at A and ends at B. Travels with different speed. So it doesn't matter if the distance and displacement are same here. So average speed and average velocity will be same in this case. Third, what does the odometer of an automobile measure? Yes. Everybody knows what is odometer? Everybody knows what is odometer. The meter स्कूटर पे जो दिखाता है ना 10, 20, 40, 80 किलोमीटर पर आवर, तो यहाँ पे ओडोमीटर क्या है? यहाँ पे डिस्टेंस लिख के आता है ना गाड़ी में कितना किलोमीटर चल रहा है, ट्रिप डिस्टेंस. That is distance is called odometer. Understood? So every vehicle has a meter, which is speedometer, which shows the speed, and odometer, which shows the distance. Okay? So right now, so in numerical we will come across odometer. So what does the odometer of an automobile measure? It measures the distance covered, not displacement. It is the distance always. Fourth, what does the path of an object look like when it is in uniform motion? Straight line. Okay? Everybody understood this? What does the path of an object looks like when it is in uniform motion? Uniform motion means equal distance covered in equal interval of time. Right? So it will be straight line. Now, fifth, during an experiment, a signal from a spaceship reaches the ground station in 5 minutes. What was the distance of the spaceship from the ground station? So you have to calculate the distance. The signal travels at the speed of light, that is 3 into 10 square meter per second. It's all good. Don't see the answer. Don't cheat yourself. what is given here? You have a spaceship. And this is the ground station. Okay. So it sends the signal to the ground station. Let us say the displacement is S. Right? What is the time given?
5 minutes.
5 minutes, which is 5 into 60 seconds. 300 seconds. Okay. And speed of light. So speed of light symbol is C, not V. Okay. 3 into 10 raised to 8 meter per second. Right? So since V is equal to S by T, you have to find S. S is equal to V into T. So in this case, V is equal to C. So how much is this? 3 into 10 raised to 8. T is 300. So this will be how much? 3 3s are 9 into 10 raised to 10. 8 and this 2 0. Okay. So the distance of the spaceship is 9 into 10 raised to 2. Is that correct? Meter distance. No? What do you have to find out? What was the distance of the spaceship? So it has to be meter. Okay. You have 2 more minutes. And example 8.2 is slightly big. Anyway, let's do it. This is in-text question, huh? In-text question. This page is 102. Next is example 8.2. So, what is given is okay, you take it as a homework, okay? I think we will not have time to do this. So, read this 8.2 and example 8.3. Okay, this is in NCRT. This page is 102. Okay, so read these 2 examples. The solution is given. Discuss in the next class. Okay. Sure.
What's that?
So देखो कि सारे सारे वीडियो का नुकसान देखेगा
Okay.